there, we are on Unit 2, Lesson 2, which is regrouping with decimals. One of the first things we need to go over is our vocabulary. Our main vocabulary word for today is trailing zeros. Trailing zeros. Trailing zeros refers to zeros added at the end of a decimal number that do not change its value. I know that we have talked about things like 2.1, which is 2 1/10, is the same as 2 10/100ths, or 2 100,000ths. These are all equal. These are equivalent decimals. Just because the zeros are there does not mean that it changes the value. All that does is holds the place in case we need to make sure that we line up our place values. So with that being said, let's look at what Lesson 2 holds for us. So, when adding or subtracting decimals, we rewrite the problem vertically, keeping the decimals lined up. So, when adding or subtracting decimals, we rewrite the decimals, keeping the decimals lined up. So, if we had 5.8 plus 3.4, the best way that we could do this is to make the problem vertical instead of horizontal. This is horizontal. We want our problem to be vertical, which is up and down. So instead of 5 plus 8 plus 3.4 that way, we would do 5 8/10 plus 3 4/10. And we would make sure that our decimals are in line with one another. Our decimals are the most important thing. They have to be in line with one another. Once we do that, there's an easy way to complete this. So the first thing we do is we start just like when adding regular numbers. We start with the smallest place value. So first we're going to line up decimals. Then we're going to start with the smallest place value. And we're going to regroup if necessary. So 8 plus 4, we can do this one of two ways. We can draw 8 and then add on 4. We can do 8 and count on 4. Or if you don't need to do that and you know that 8 plus 4 is 12, that's fine. 8, 9, 10, 11, 12. I can't put 12 right here. So that's the same thing as saying 1 whole and 2/10. So I'm going to put my 2 here. My decimal point is brought down, and then I carry this 1 over into the next place value. 10/10 equals 1 whole. So just like in a fraction, 10/10 equals 1 whole. That's what this 1 means. It means the same thing as 10/10. If we have 12/10, it's the same as having 1 2/10. That's our decimal right there, 1 2/10. So we put our 2 in the tenths place, carried our 1, and we have 5, 6. 6 plus 3 is 9. We don't have to carry anything over into the next place value. 9 and 2/10 would be our answer to that problem. Now, again, the decimal point in the answer must line up with the other two decimal points. If we are adding decimals that do not have the same number of place values, this is where that whole idea of the trailing zeros comes into place. For instance, let's say we have 35 and 724 thousandths. And we have 15 and 8/10. And we're going to add these two numbers together. Well, we again line up our decimals because that's most important. Once we line up our decimals, we can look at our other place values. Tenths, hundredths, thousandths, ones, and tens. Notice that on our second number, we don't have any hundredths or thousandths. So we're going to put in there what I like to call ghosty zeros. They're just placeholders. They're not even real zeros. They just hang out there. They don't change the value of our number. They don't add anything to it or take anything away from it. It just makes it easier for us to subtract or add. So if we add 4 plus 0, our answer is 4. 2 plus 0, our answer is 2. 8 plus 7, do the math on that. 8 plus 7 is 15. We can't put 15 in here. So 15/10 is exactly what that means, which is the same as 1 and 5/10. So we put our 5/10 in the tens place, and we carry our 1 over to the ones place. Now, if we have 5 plus 5, we know that's 10 ones, and we have 11 ones. If we have 11 of these little ones, we know that we can make a 10. So we would have 1 1, and we would carry the 10 over into the tens column. 3, 4, 5. Our answer would be 51 and 524 thousandths. 51 and 524 thousandths. So again, we continue adding until all place values have been completed. We start on the left, which is the smallest place value, and we move to the right until all of our place values have been addressed. Let's do another example where we have multiple numbers that we're adding. Let's do 14.67 plus 9.3 plus 16.015 plus 5. Now again, the first thing we want to do is we want to put our place values in the right place by lining up the decimal points first. The way I'm going to do this to make this easiest for myself is I'm going to make a place value chart. I'm going to put my decimal point right here in the middle. And then I have my ones, my tens, my hundreds. So this is ones, tens, hundreds. This is tenths, hundredths, and thousandths. And let's start with our first number, 14 and 67 hundredths. Well, looking to each side, before the decimal, we have 1, 4, decimal point, 6, 7. Notice we are lining up our decimal points. That's the piece that matters the most right now. The next number is 9 and 3 tenths. The next decimal is 16 and 15 thousandths. 16 and 15 thousandths. And the last number is 5. Now I made this tricky for you on purpose. When we write the number, it's the same as 5.0, but we always know that the decimal point comes after the 5 because this is in the ones column. Now remember, we can put in these ghosty zeros to help us. This just helps us keep our place value straight, where we're adding and what we're doing. So we are adding based on the signs from up in the problem. We know that 5 plus 0 is 5. 7 plus 1 is 8. 6 plus 3 is 9. The decimal point is brought down. Then we have to add all these numbers in. So the way I do this is I try to make a 10. So 6 plus 4 is 10. Then I go with the next highest up. Plus 9 is 19. 20, 21, 22, 23, 24. 24, I can't put 24 in there. Just like before, that means that I have 2 10s and 4 1s. I'm going to put 4 1s here, and I'm carrying my 2 10s into the tens column. Then I have 2, 3, 4. My answer is 44 and 985 thousandths. 44 and 985 thousandths. Remember to use trailing zeros if necessary to help identify the place